past paper question is from the Advanced Higher 2013, written 9B. And the question asks us to calculate the percentage by mass of the nickel in the impure sample of the nickel 2 sulfate. So what we have here is we have our nickel ion, which was found in our nickel 2 sulfate, and we have reacted it quantitatively with the dimethyl glyoxime, and this is the transition metal complex that was formed. This is our precipitate. So the first thing that we want to do is we want to do a ratio. So we have got one of our product, which is our precipitate. How many nickel ions are found in that precipitate? We have 1, so that's our mole ratio. Now the question asks us to work out the percentage by mass. So on the left hand side, which is to do with the nickel, we're going to do percentage is equal to mass over sample times by 100. We can sub in the sample size, which would be given at the beginning, and we can see that we were given 0.968 grams. To complete this, we need to know the mass, which means we would need to calculate the mass of the nickel ion. So mass is equal to N times GFM. And when we look up in our data booklet the GFM of nickel, that comes in at 58.7. So to complete this, we have to work out the number of moles of nickel that was produced, and that's the result of working out the number of moles of our precipitate which is formed. So on this side, we're going to do N is equal to M over GFM. The mass of the precipitate which was formed was given as 0.942 divided by, now luckily they've given us the GFM, which is 288.7. So I'm going to pop that into my calculator. 0.942 divided by 288.7. That gives me the number of moles as 3.262902667 times 10 to the minus 3. I'm going to pop that underneath here, so I'll write that out again. 3.262902667 times 10 to the minus 3, and when I cross multiply that, it comes out as the same number of moles, because I would times by 1 equals divide by 1 from my mole ratio, and it's the same number of moles. What we would then do is we're going to transfer this number into our calculation to work out the mass of nickel. So we times that by the GFM, which we'd worked out as 58.7. And that gives us a mass of 0.19153 to 3866. So we don't round at this point, we always want to substitute in and round at the final step. If we substitute that in, divide it by 0.968 equals times by 100, that would give us a percentage mass of 19.786037. But at this point we want to round. What we want to do is look at the number of significant figures that are given in the question, which is 4. So I'm going to round that to 4. 1, 2, 3, 4. So that's going to be my rounder, which means 19.79%. This past paper question is from the Advanced Higher 2011, written 5B Part 3. The question wants us to calculate the percentage mass of nickel present in the hydrated salt from experimental results. So we do percentage is equal to mass over sample times by 100. We should be able to find the sample size in the text, and what we can see is the sample size is given as 2.656, which means we need to calculate the mass. Mass is equal to N times GFM, and we're looking for the mass of nickel. So the RAM for that is 58.7. So to complete this, we need to work out the number of moles of nickel, which we've got in our transition metal complex. Now what we can see here for one of the transition metal complex, we can see that 1 nickel reacts with 1 EDTA. It reacts in a 1-to-1 ratio, and that's because EDTA is a hexadentate ligand and forms a 1-to-1 ratio, forming an octahedral complex. So to work out this, we're going to have to work out the number of moles of EDTA that we used in the reaction. So we do N is equal to C times V. The concentration is given as 0.110 times by the volume. Now we're given a table, which means we need to work out the average volume. And that's when we're using our concordant results. So that's when the results of the total volume is within 0.1 of each other. So we're going to use 23.5 plus 23.6 for titer 1 and titer 2, divided by 2, which will give me an average titer of 23.55. So we do 23.55 divided by 1,000 to put it into litres. 23.55 divided by 1,000, answer, times by 0.11. And that will give me the number of moles is 2.5905 times 10 to the minus 3. This is the actual number of moles that reacted, so I need to put that in for my ratio. 2.5905 times 10 to the minus 3, cross multiply to scale for our nickel. So we would times by 2.5905 times 10 to the minus 3 times by 1. Answer divided by 1, and it'll come out the same. So that's the number of moles of EDTA. But what we can see is at the start of stage 2, it says 25 centimetres cubes of the nickel sulphate solution were titered, which means 2.5905 times 10 to the minus 3 was found in the small sample or aliquot of 25 centimetres cubed. Now this was extracted from step 1 of our standard flask, so we have to scale for that. So to do that, we would take 2.5905 times 10 to the minus 3, times it by 100, and answer divided by 25 to scale for the number of moles of nickel, which must have been in our standard flask, which is 0.010362, and that's the number of moles that we're going to transfer. So we then substitute that into here, so we'll times that by 58.7. and that will give me a mass of 0.6082494. I substitute this into this equation, divide by 2.656, answer times by 100, and that will give me a percentage mass of 22.90009. Look at my significant figures. The maximum they've given me is 4. 1, 2, 3, 4. That's my rounder, so it'll come out at 22.9%.